All right, so we're looking at solving and graphing compound inequalities today. We're going to start with reviewing how compound inequalities work, which we looked at in the previous lesson. So we're going to start with our first and is already written in the combined form. I have 5 is less than x is less than 9. We can read this as x is between 5 and 9. If they had an equal to bar on both of these, they would say inclusive to let you know that those endpoints were included. If they had one of them underlined, they would tell us which number was included. But for the most part, this is x sandwiched between 5 and 9. 5 is a smaller number, 9 is a bigger number. That's why the symbols are the way that they are. And then we're going to do this differently than we did in the last lesson. We're going to rearrange this and write it as separate inequalities. So you could take the 5 is less than x and turn it around and make it x is greater than 5. Now, in order to not change the meaning, you have to make sure that it's still opening to the x. X is still bigger. And then we could write it as and x is less than 9. So I just turned that first one around. You wouldn't have to turn it around either. You could just break it apart. But I know a lot of you like to have the x on the left-hand side, since this gives you kind of what the end of the arrow, the direction it's going to go. So I have 3 lines on here. On the first line, we're going to look at just x is greater than 5, what that looks like. Since there's no equal to bar, we do not fill in the circle. And then the numbers bigger than 5 are on which side of 5, right or left?
Right.
To the right, to the right, to the right, to the right. So all these numbers off into infinity, and you don't have to shade all the way to the end. If you put an arrow on it, that goes out forever. On the next line, we're going to do x is less than 9. So we're going to put a circle at 9. It is not filled in because there's no equal to bar. And then it goes out this way. So I'll show you, you don't have to shade all the way to the end. You could just put an arrow showing all the numbers forever on this side of 9 are smaller than 9. When we put them together like this, we're looking for where x is between 5 and 9. We're looking for numbers that are bigger than 5 and less than 9, which are going to happen between here and here. So if we look at where these graphs overlap, they overlap between 5 and 9. So for sure we're going to shade between 5 and 9, all of those numbers. And at the endpoints, because I need to have the number on both of them, they have to overlap. This 5 doesn't count because up here it's not technically, because it's not filled in. It's not equal to. Okay. We didn't have the equal to bar. So down here we're going to use that as our endpoint for 5. So and same thing here at 9. So 5 and 9 don't count, but everything in between does. Okay. And that's because we want it to be bigger than 5, not equal to 5. It doesn't have the equal to bar.
Okay, I get it.
Okay? And so when we're doing ands, it's overlap. Now, if you just have this, there's a shortcut where you can just go ahead and put the circle at 5, the circle at 9, and fill it in between, because this is telling us x is between 5 and 9. So it's a little backwards from the way we did it in the first lesson, but hopefully that'll help us kind of solidify how this works. Now, we're going to go down the left-hand side and do all of the and problems first. Then we'll go down the right side and do the ors. So we're going to come down and look at this first example that says solve and graph. Now this is a weird compound inequality. Notice x is not by itself. I have 4x minus 2.
We have to, do that.
So we're going to have to solve it. So see all this space down below the graph? We're going to rewrite the equation down here. Or it's an inequality, I'm sorry, not an equation. It's an inequality because it's got less than signs. And we're going to solve for x. Now, you've never done a 3-part thing like this, but it works just like solving an equation.
Ooh, we add 18.
So, nope. So pretend this left-hand part wasn't there, and I'm just solving for x. What would I do first?
5.
Nope.
Add 2.
I would add 2 first. So I'm going to add 2 here and add 2 here. Now, the difference, because I have this other piece here, is I'm going to add 2 to that negative 18 as well. You always undo the addition and subtraction first when you're solving an equation or an inequality. And then we have to go through all 3 parts and rewrite it. So the middle part is now 4x. The right-hand side I have 18 plus 2, which is 20. And then the left-hand side, I have negative 18 plus 2, which would be negative 16. Now, I still haven't quite solved for x. I still have 4x.
We have to divide now.
So now we divide by 4. And that should always be your last step because that's attached to the x that wants to be there. We have to kind of pry it off. So when I cross that off, negative 16 divided by 4 is negative 4. Less than x is less than 5. So this is my solution that I'm going to box.
4
is less than x is less than 5. So that's the solution. I'm going to box that because that's my answer. But then I also have to graph it on the number line. When it's written as this compound inequality this way, there's a shortcut. You don't have to do all the separate graphs. Some of you didn't catch that yesterday, so make sure that you're listening today. So I'm going to start at negative 4. The symbol closest to negative 4 does not have an equal to sign. So at negative 4, I'm just going to put a circle. I look at 5. The symbol closest to that is just less than. It does not have an equal to sign. I'm just going to put a circle at 5. And then x is between those. So all of the solutions for this are between these two numbers. Any number that I pick between negative 4 and 5, like I could pick 1 and put it in there, it would make this true. And you could check that. I'll just show you on this first one. Let's say I pick 1. Okay, let's see if 1's part of my solution, and I put it in here. I would have 4 times 1 minus 2, which would be 4 times 1 is 4 minus 2 is 2. So if I put that in there, negative 18 is less than 2 is less than 18, I can see that that is true. It checks out. And technically, any number along here would make it true. Just testing 1 point for these might not be enough. You'd have to check several to make sure that you did all the math correctly, because there could be like one end you may have in the wrong place. But that's what we're looking at. There's an infinite number of solutions in here too. You can have halves and quarters and 0.5s and all kinds of weird, and 0.2s and all sorts of weird stuff in here. There's a lot of solutions in here that would make this true. Okay, so let's go ahead and look at the one down below this. So I'm going to rewrite it just because the program that I use sticks that number line kind of in the way. So I'm just going to copy it down here so that I have room to work this out. So you want to focus on the part in the middle. We're trying to get p by itself. You don't mess with the 10 yet. The 10's attached.
We're going to minus 7.
We're going to minus 7. That's correct. So we're going to subtract 7 here. I'm going to subtract 7 here. I'm going to subtract 7 over there. All 3 pieces. So negative 3 and negative 7 make negative 10. Greater than or equal to. Now there's a minus sign here. When I bring this down, it makes it into negative 10p. That minus does come down with that. And then over here, if I put negative 13 and negative 7 together, I get negative 20. Okay? So now, what's my next step to get p by itself? Now, when we divide inequalities by a negative, we have to flip them, which we talked about last week. So negative 10 divided by negative 10 is 1. This symbol goes, whoop, it flips. In the PowerPoint that we had, it made a little sound. Okay, here, we're just going to have p. And then this one also flips, whoop, because we divided by a negative. And the reason that that happens is because we're changing all of the signs. All of the negatives are changing to positives. And so that relationship, if I left it the other way, it would say that 1's greater than 2. We know that that's not true. So it was true with negative 10 and negative 20. Negative 10 was bigger than negative 20, but 1 is not bigger than 2. When we change all the signs, you got to flip the inequalities around.
Can I sharpen my pencil?
Yep. Okay, so we're going to do this the easy way. I'm going to start at 1. I do have an equal to sign. What does that tell me about the point at 1?
Fill in the circle.
Fill in the circle. So I'm going to go to 1 and I'm going to fill in the circle. Why am I filling in the circle? Because there's an equal to sign. When I fill in that circle, that means this point counts. It is part of the solution. Now at 2, am I going to fill in the circle?
No.
No, because there's no equal to sign. So these are really close together, but that's okay. And then P is the solution. It's in between them. So you're going to get this tiny little bar in between them. So what kinds of numbers would be a solution then that's between 1 and 2?
1.2.
1.2, 1.5.
1.4, 1.5.
Yeah, so there's lots and lots and lots of numbers. I could do 1.0398. I could do 1.987. Anything that's between 1 and 2 would be a solution. It looks like it's a little tiny piece, but there's actually an infinite number of numbers in that tiny little piece that would be a solution.
You could use 1.
And you could also use 1 because 1 is equal to, which the way that's set up, 1 would also be a solution. Correct. All right, so let's go down to the last one of the ands. So this one is not written as a 3-piece thing, and we cannot combine it because the part with the variable is different. So what we have to do is we're going to have to solve these separately. So I have m plus 5 is less than or equal to 1. How do I solve that?
Wouldn't you? You would subtract, yeah.
Yeah, so we'd subtract 5. Good. We're getting there. And so I'd have m is less than or equal to negative 4. Okay? Then over here, I have to solve the other one, which looks completely different. It has an m plus 3. And that's why they couldn't put them together. It's because they had a different expression over here where the variable is. How do I solve m plus 3? So subtract 3. Good. So we're going to get m is greater than 2. And we're going to figure out where that goes. So you could do a little practice thing kind of off the graph. I didn't leave myself a lot of room. So less than or equal to 4 would be here. And it would go to the left. Greater than 2 would start here. Oh, it's negative 4. I'm sorry. So let me start that down here. You are absolutely correct. I should start at negative 4 and go less than. So at negative 4, it's less than, it goes this way. And at positive 2, it goes this way. Now with ands, we're looking for overlap. But I don't have any overlap. So, oh my gosh, what do I do? Adrian.
You combine them and it becomes negative 4 is greater than.
I can't combine them. They don't overlap. This is an and. When I have an and, I'm looking for the numbers that are on both. So, so we put no solutions. Good. There are no numbers that are on both of these pieces. Okay, so technically that's not my graph at all. There is no graph. You could X out the graph because there is no solution. Because there are no numbers that are bigger than 2 and smaller than negative 4 at the same time. It just doesn't happen. And so if you get one of those, you just write no solutions, or you can do the little null set sign that I showed you guys before. Okay, so those are the ands. Now the ors are a little bit simpler, I think, but you have to kind of switch your brain, and you have to pay attention to whether it says and or. So we'll go up to the top of the page over here where we talk about the ors. Okay? So or means union, which basically means any number that was part of either solution is fair game. So we have x is less than 5 or x is greater than or equal to 9. On the first graph, we're going to do x is less than 5. So we put a circle at 5. Do I fill it in?
No.
No, it doesn't count because I don't have that equal to. And then we go to the left because those are where the numbers are less than 5. Then we're going to do x is greater than or equal to 9. So do I fill in the 9?
Yeah.
Yes, because 9 is part of the solution because it says it can be equal to 9. And then the numbers greater than 9 go which way?
Right.
To the right. Good. So my solution, my numbers are either less than 5 or greater than 9. So on my final solution down here, we're going to do x is less than 5 or x is greater than or equal to 9. And what we do is we just put both of them on the same graph. There's 2 pieces to the solution, and there's solutions over here, and there's solutions over here, and it's all just one big happy weird family. Okay? It's all on one big graph. So when you have an or, you don't throw out any solutions. Any solution that was on this one or this one gets included in your final answer. Okay? So these will never be combined like we did over here. This only is for ands. Okay? So when we have ors, they're never going to be combined into one big inequality. It cannot happen. All right, so let's go down and look at our first example. we are going to have to copy these down here. So if you want to go ahead and take a second to copy it all down, you're going to need room to solve that. Okay? So on the first one, what would I do first?
Okay, so
Add one.
Well, it's a positive one, so if I add one, I'm going to get 2.
you would subtract one.
So since it's positive, I want to subtract. And it's really easy to make that mistake because this minus sign on the back side makes your brain want to think it's negative, but that goes with the 10. I always hated those because it's just kind of a pain. So that cancels out the 1. And then I have negative 10x is greater than 100. Now what do I do?
Yeah, you
Divide by negative 10. Ooh, I'm dividing by a negative. So notice I went from negative on the left side to positive, and this side went from positive to negative. So now I have to flip the sign.
It's more than or equal to.
Yeah.
Right, but we just flipped it.
No, yeah, but like on the actual problem.
Equal to.
Oh, equal to.
Yeah.
Okay, so I need to put an equal to sign on there. Thank you. Okay, so that's part of my solution. Let's go over here and do the other piece. What would I do first? Subtract 1 from both sides. And that leaves me with negative 8x is less than, I did get the symbol right this time, and this will be negative 32. Now what?
Divide by negative 8.
Divide by negative 8. Good. And so we'll get x, and this will be positive 4. Notice when we divide by negative, it goes from negative to positive, negative to positive. When that happens, that's when we have to flip the symbol from less than to greater than. Anytime you divide by a negative, or technically multiply by a negative, that switches. And so when we write our final answer, we're going to put a big fat or in between these, and this is what it's going to look like. X is less than or equal to negative 10, or x is greater than 4. You have to write the word or in there and kind of put it all together. So this is just going to go on the number line all together. We're going to put a point that's filled in at 10 because it had an equal to, so now that you guys have straightened me out, and then do that arrow this way. So even though it was greater than in the original problem, the answer has less than, so it's going to go to the left. And then x is greater than 4. We put our circle at 4, not filled in because we don't have equal to, and to the right. So my solutions are here or they're over here. And you just put all of it on the graph. Okay? So with the ors, it's pretty simple. You don't have to worry about overlap. Well, you do if it happens, and it's a special case. We'll see in a little bit. But there's usually not overlap. It's just here or it's over here. It's not here and here at the same time, which wouldn't work. All right, so let's look at the next one. So we're getting close to done. 2 plus 9n is less than or equal to negative 43. I'm just going to write these down here so I have room to work it all out. So take a moment, rewrite that down below. Okay, and don't forget to do both of them because sometimes people do that too. Okay, so let's solve the first one. What's my first step? Subtract 2 from both sides. 9n is less than or equal to negative 45. Then what's my next step? Divide by 9. We want to get n all by itself.
It's going to be 5 over there.
Yep, and it's going to be negative 5 because negative divided by positive is negative. So n is less than or equal to negative 5. Oh, I don't want to box that yet. I started to. We're not done yet. That's what makes this so hard because there's 2 pieces. You have to remember to do them both. Yep. Okay, so we're going to solve the next one. So it's very similar. We're going to subtract 1 from both sides. We get 5n is greater than or equal to, this will be negative 10. Divide by 5, divide by 5. We get n is greater than or equal to negative 2. So when I write my solution, I'm going to put a big or in the middle of it. I'm going to box both of these. It's either n is less than or equal to negative 5 or n is greater than or equal to negative 2. So both of these have equal to signs. So we can put a point at both. Less than or equal to 5 would be a point at 5 going to the left. That's where the numbers less than negative 5 are. And then greater than negative 2 would start here and go to the right. So on a normal OR problem, you're just going to get a couple of different pieces that all go together on the graph as one big happy family. Nobody gets left out. Okay, we have one more problem. Everybody doing okay? All right, so down here, these are only one-step inequalities, which is fine. They won't take as long. I'm going to go ahead and copy those down here so we can solve. So I know this is hard because my b's and my 6's sometimes look the same. But this is b over 6. Maybe I'll make it a capital B just so it sticks out a little bit. So how would I get b by itself here if I have b divided by 6? Multiply by 6. So I'm going to take this side times 6, cancels out, take this side times 6, and then I'll have b, big B, or little b, whatever you want to call it, greater than negative 6. So that's all solved, just one step. What do I do on this one?
Subtract 5.
Subtract 5 on both sides, so I'll get b is less than 0.
It's
Okay.
less than 1 because it's 6 on 5.
Oh, it is 6. Man, I'm having a hard time today. So that was 6, which will make this 1. And I wrote a 5 instead of b, so I'm really having a hard time. B is less than p. Okay, so...
Negative 6 isn't on
And negative 6 isn't on the graph. So let's add that to the graph just to think about. So here's negative 5, negative 6. It'd be over here somewhere. So greater than negative 6 would start here and would go to the right. That already looks a little weird to me. And then b is less than 1 would start at 1 and would go to the left forever here. So this one's going forever to the right. That one's going forever to the left. And we're including any point that's on either graph. So what's going to happen in my final solution? All real numbers. Technically, if you really wanted to graph this officially, we would fill in the whole number line and say, oh, it's going to be everything. And what we're actually going to write, we are not going to box this down here. We're going to either say all real numbers like this, or we're going to use that symbol for the real numbers that we learned about last year with the 2 bars. And that represents the set of real numbers.